Alright guys, so this unit is all about transformations. Let's go ahead and get the definition, this first definition out of the way here, and then we'll talk a little bit more about what a transformation actually is. So a transformation that does not change the size or shape of a figure is called a rigid motion. So let's go back to what a transformation is. So transformation is just a fancy math way of saying that we are moving an object. So we can have a couple of different types of transformation. So a translation, which is this first example here, is where we're just taking an object and we're sliding it over left or right, or we're sliding it up. In this example, we've moved this over to the right and then up a little bit. So that's what a translation is. It's just sliding an object around on our graph. Reflection, which is this example, is where we're just reflecting the image across some line. So in this example, they've reflected it across the y-axis. So just like when you see in a mirror, it's just the flipped image of it. The next example down here is a rotation. A rotation is where we're just going to turn around some given point. So in this example, we are rotating around this point of origin, which is 0, 0. And so you can see if you do a 90-degree rotation, this shape here becomes this one. So let's see. So there you go. So that's easy what a rotation is. These are all pretty simple. And then lastly is a dilation. A dilation is a shrink or a stretch. If you think about it like when you go to the eye doctor and they dilate your eyes, your pupil gets bigger. So it's the same kind of a thing. When we have a shape and we do a dilation, the image is going to get bigger or even could get smaller, kind of like when we are playing on our phones and we want to zoom in on an image or zoom out to make it bigger or smaller. That's a dilation. A dilation is an example of a non-rigid motion. So you can see that right here. All right, so let's jump down to example 1. We're going to use coordinate notation, which just means we're going to write it as a point to describe the transformation of these points here for these two triangles. So if you'll look here at our original, the original is the point P. That is our pre-image. So this is our pre-image, and after we do the transformation, which this looks like we're just going to slide it over, it's going to be a translation. So after we do the transformation, each of our points gets this little hashtag mark up here. That is called P prime, and that lets us know that this is the point after we've moved it or after we've done some sort of transformation on it. So let's look and see where the point P prime is. So P prime is right here. So that is the point 1, 2, up, 4. So that is the point 2, 4. All right, so then we're going to go to Q prime. Q prime is at the point 1, 1, and R prime right here is at the point 5, 2. So the next thing it wants us to do is describe the algebraic rule. So we need to look at our pre-image and see what we've done to get it to the image. The image is the final location after we've moved it. So from P, we went in this direction from here over to here. This was moving in that direction 6. So if you're not sure how I got that 6, all I did was just count over 1, 2, 3, 4, 5, 6. And then to get down to the point, I went from here down 1. So when we're talking about our graphs and we go in this direction, that's going to affect our x values. So whatever our x value was, we went this direction, so that's a positive direction on our x-axis. So we added 6. So then we're going to talk about going down. So when we go down, that affects our y. So if you look at our y-axis when we go down, that's a negative motion because our numbers on the y-axis are getting more negative as we go down. So we took our y value, whatever it was that we started with, and we actually subtracted 1. So let's see if that rule applies to q prime or to r prime, because we know it applies to p prime because we just did it. So let's look. So if we start with this x value of -5, and we add 6 to it, -5 plus 6 is 1. So that is true. That rule does apply. And then let's do the same thing for our y. So 2, that's our y value, and we're going to subtract 1. So 2 minus 1 gives us a 1. So there you go. Our rule does apply, and we did it right. All right, so let's jump over to the inside of our notes. We've got another example in here. So we're going to draw the image when ABCD is translated along this. So we're going to go take our x values, subtract 5, our y values, we're going to add 4. So we can do this one of two ways. I'm going to do point A the algebraic way. So we start with the point A, and the point A is at 1, 2, -2. So 2, -2. And it's going to go to, or transform, or slide over back to the point A prime. That's going to be our new point, where it starts here, and this is our stopping point. So if we take our x value, which is 2, and we were to subtract 5, that's this part right here, and then we're going to take our y value, which is -2, and we're going to add 4 to get that new point. So that means that our point, if we do this algebraically, 2 minus 5 is going to give us a -3, and -2 plus 4 is going to give us a +2. So we would have a point at -3, +2, right there. So that would be the point A prime. So we can do it algebraically like this, or we can actually just slide these points over. So if we're going to go, if our x needs to shift negatively 5 spots, we're going to go that direction because that's negative direction for x's. And then it's going to go positive direction for the y's, 4. So it's going to go up 4. So if I go over to my point B, and I go over 5, 1, 2, 3, 4, 5, and then up 4, 1, 2, 3, 4, that would be B prime. Then I can do the same thing for the points C and the points D. So the point C is going to end up right here at C prime, and the point D is going to be right here at D prime. And then you always want to make sure that you do connect your dots back the same way that you started, so you end up with the same shape. All right, so that is that. Those are translations. That's when we're shifting an image left or right or up or down. Now we're going to talk about rotations. So we've got 3 different rules here for rotations. We've got a 90-degree clockwise rotation. So a 90-degree clockwise rotation, sorry about that, is going to take a point over one quadrant. So when we go counterclockwise, we go from here around in this direction. So we are going to number off our quadrants, and our quadrants are numbered 1, 2, 3, and 4. So for example, if I got the point 4, 3, and I wanted to apply a 90 degrees clockwise rotation, I'm going to end up in this quadrant. So what this rule tells us is that we're going to switch this x and y value. So we're going to end up with a 3, 4, and then this, our x would be negative, which makes sense because our x values are all negative in this quadrant and our y values are all positive in this quadrant. So we would end up at the point -3, 1, 2, 3, 4. So the same thing, if we started off here with 180-degree rotation, if we started in the quadrant 1, that would end us up in, that would put us at 90-degree, 180 would put us in quadrant 3. If we started in quadrant 1 for 270-degree rotation counterclockwise, it's going to rotate us all the way around to quadrant 4. Now, something that you want to know is that this rotation is the same as a 90-degree clockwise rotation. So if you start here and you go 270 degrees counterclockwise, that would do the same thing as if you started here and went 90 degrees clockwise. That's all that's saying. All right, so let's look at our first example. So we're going to write the coordinates for the rotated image, then graph both figures. So I'm going to start with my pre-image, and I'm going to do my pre-image in green so we can see what that looks like. So I'm going to go ahead and graph it. -2, +2, -6, +4, -4, -3, 3, -4, 1, and -4, 2. Okay, so once you've got these points all your points plotted on the graph, it might be confusing as to how to connect them so that you get the shape to look the right way. So you just want to connect them like you did when you did connect the dots when you were little. If this was the first point that you plotted and this is the second point, you want to connect point 1 to point 2. So we're going to start here, connect to here. Then we connect to the third point we plotted, then to the fourth, the fifth, and so on until we've created our shape, which should look like an arrow. All right, so we talked about doing a 90-degree rotation. So if we are doing a 90-degree rotation, we are going clockwise in that direction. So if we are starting in quadrant 2, that means that when we do our 90-degree rotation, it's going to end up in quadrant 3. So our rules for 90-degree rotation says that our x and our y are going to flip. So we're going to flip the x and y, and then obey the sign, the quadrant sign. And I'll tell you what I mean by that. So in this quadrant, if we obey the signs, whether the x values are negative or positive, or the y values are negative or positive, is what I mean by that. So if we obey those signs in this quadrant, let's think about it. Our x values are all negative. So our x's are going to be negative, and our y's are also all negative. So we're going to flip this x and the y. Let's change colors so we can graph it in a different color so we can see it. All right, so our x and y flip. So they're going to be flip it 2 and 6. And then it says that since we're in quadrant 3, they both need to be negative. So this is going to be a -2 and a -6. So now hopefully that makes sense what I wrote there for our notes to watch. All right, so we're going to do the same thing to the next one. We're going to flip the x and the y, so we've got a 6 and a 4. We're going to flip it, so it's 4 and 6. And since we end up in quadrant 3, they both need to be negative. So they are both negative. And that's going to be the same all the way down for all of our points. So we're going to end up with a -4, -4, -5, -4, -3, -3, -1, -4, and a -2, -4. All right, so now we're just going to go ahead and graph these points, and we will be able to see our rotated image. So we've got a -2 and a -6, -4 and -6. All right, so then I'm going to start here and connect them in the order that I graphed them so that I don't connect the wrong ones together. All right, so you can see that this is what our image is going to look like after we've rotated the pre-image 90 degrees counterclockwise. And so you can kind of see if we hold our page down at that origin point and we rotate it 90 degrees, you can see that that is what that shape would look like. All right, so let's jump down to the next example. So our pre-image is the same thing that we started with in example 2, which is kind of nice because we already know what it looks like graphed. So I'm just going to go ahead and graph that really quick. Connect our dots. All right, so this time we are going to do a 180 degree rotation. So a 180 degree rotation counterclockwise means that I'm going to go from quadrant 2. Quadrant 3 would give me a 90 degree rotation, so I'm going to actually jump all the way over to quadrant 4. So every time I do a 90 degree rotation, my X's and my Y's flip, just like they did in the example that we did above. So we flipped them here, and then when we jump over to this to do another 90, because 90 plus 90 is 180, that means that our X's and our Y's are going to stay the same. And if you peek back over here to this little rule, it shows us that a 180 degree rotation, our X's and our Y's are going to stay the same. So our X and Y's stay the same. And then we just always obey the quadrant signs. So let's talk about what our signs are going to look like for our X values and our Y values in quadrant 4. So our X values are all going to be on this axis. So those X values are all positive. So that's good to go. But our Y values are all negative. So that's what each one of our points is going to look like. So our X and our Y values stay the same. So we still stay at 6 and 2. But our X value stays positive, just like we talked about, and our Y value is going to become negative. So same thing for this next point. If we started off with negative 6, positive 4, they stay in the same spot. We don't flip them. So it's going to be a positive 6 and a negative 4. And we're going to do this the whole way down. So we end up with a positive 4, negative 4, positive 4, negative 5, positive 3, negative 3, positive 4, negative 1, and a positive 4, negative 2. Then all we need to do is just graph them, and we will be able to see what our pre-image looks like as our image. All right, so we are going to graph the first point at 6, negative 2. So we're going to go 6, negative 2, 6, negative 4, positive 4, negative 4, positive 4, negative 5, 3, negative 3, 4, negative 1, and 4, negative 2. And then that shows us what our little arrow looks like after we've rotated it 180 degrees. All right, well, hopefully that explains everything to you guys. Go ahead and work through the practice problems I've posted online. If you have any questions, let me know.